Okay, so today what we're going to do is we're going to continue building the algebraic system. Now, I know you've seen a lot of this in year 7, but, guys, you're going to see the same types of ideas again this year because it is the building block or the foundation of the mathematics that you're going to use from this point forward, right? And so if you don't know how to work it, then you're going to struggle from now on. Yeah? So, what I need for you is, I need you to, first of all, as always, like you always do, because you're so perfect and good, pay attention. And then, I also need for you to do your work and ask any questions of when we're working through these. Now, here's the way that what we're going to do, though. I'm going to get through what I have to say, and then I will ask for questions. So if you have some questions, hold off because generally I'm going to answer them anyway. And secondly, you need to be focused not on thinking of what could happen, what might happen, what could have happened, or what you did over the weekend, etc. And you need to be focused on what I'm saying so that you can understand what's going on. Okay? Can we all agree on that? Yeah? Okay, so here we go. So what we're going to do today is we're going to talk about an algebra skill that is critical. If you don't understand this particular skill, then you're not going to be able to move forward in algebra, right? But it's quite easy because we've already built the foundations for it. So let's talk about it. Remember that the only difference between algebra and arithmetic is the introduction of the variables. Good, the letters, which are called variables. And so now our building blocks of algebra aren't just numbers, they are called, starts with a T, terms. There you are. And all terms have exactly how many parts? 4. What's the first part of every term? Then you have the coefficient. Then you have the base. And on every base, whether you see one or not, there is an exponent, which y'all aren't going to deal with as much in this course, but okay. All right. So the base. Base. The base is the thing that everything else is built on. Does that make sense? Okay. All right. So the base is the variable. So that should tell you that the variable is an incredibly important part of every term. Okay? All right. So, for example, this item is a what? Tells you what kind of thing it is, yeah? Okay? Now I have pens, plural, right? I have more of them. Did they suddenly become different objects because I have more of them? No. And that's the idea we're going to be looking at today, is how to have more objects or fewer objects. And so we're going to be talking about what's called combining like terms. This is also the title that I used on the other page, but we want to talk about this a little bit. Now, we call it combining because from this point forward, remember that when you introduce the algebraic system, the first part of every term is its sign. So those pluses and minuses don't mean add or subtract anymore. Those pluses and minuses are the signs of the terms. And we've talked about the set of integers before, right? And the rules for those. We can go back and review those, and I'm happy to give you some more help with those. But remember that the way things are combined depend on the combination of signs you have. And that's why it's called combining now instead of add or subtract. So we used to think of these as add and subtract. And you can still say add and subtract. Those don't ever go away. But remember, you might see something with a plus, but you end up subtracting. You might see something with a minus, and you end up adding. So you've got to remember that it's the sign rules or the integer rules that make that tell you how these things are going to be combined. Now we're going to start off quite simply with these because our real focus is just the like terms. But keep that in mind as we go. So we're talking about adding or subtracting. In order to be like terms, they have exactly the same base and exponent. Now, we're not going to have any exponents in today's lesson, but we will soon. But same base and exponent. And again, which part is the base? The variable part, right? So in other words, I can combine pens with other what? Pens, right? Which means I can combine x's with other what? X's. And y's with other what?
Y's.
And a's with other what? A's. But I cannot combine pens and remote controls to make one unit, right? Doesn't work, does it? This is still a pen, this is still one remote, right? And in the same vein, you cannot combine X's and Y's or A's and B's. They have to have the same base and later then the same variable. Now we're going to go through an education perfect lesson on this and to talk about what happens, but I want the steps written first so that you can, and then we'll just reinforce it with the lesson. And one of the reasons I like this lesson is because it really puts it into real life terms. And you'll see why in a minute. Besides that, can't go wrong if you have a picture of a sheep. All right, so like terms have exactly the same base and exponent. And what we will do to combine is we will combine the coefficients. So I'm using all the fancy math words. They're not. They will later, but we've learned them. Let's use them. Coefficient means the number in front, right, of a term. And then we will simply keep the base and exponent. Again, we're not going to have any exponents yet, but when we do, we need to be aware of that that's going to happen. Because if I take this pen and add more pens to it, they don't suddenly become pencils, do they? So the type of object that you start with stays the same. Do we agree? That's the way everything happens, right? Okay. All right. So now let's look at the education perfect lessons so that we and go through talking about combining. For some of you, this is going to look very simplistic, but that's fine. I want it to be, right? Okay. So here we go. So. Right? So when we're talking about algebra is all about simplicity. As you learned in some of those algebraic conventions, if you don't have to write something, we don't. Right? Remember we said if you don't have a coefficient, you assume it to be a what? A 1? We don't even bother writing it because we don't have to. We can assume it's there. And algebra is all about making things as simple as possible. And you do this all the time, whether you think of it or not. In your normal life, if you walked into this room, right, and you wouldn't say, oh, there were 10 students over here and 12 students over there. You would say that there were 22 students in the room. Does that make sense? You wouldn't say, oh, I have a pen. I have another pen. I have another pen. I have another pen. You'd say, I have 4 pens, right? We group things together to make our lives easier. And that's what we're doing here. So that's all that combining like terms is doing. It's grouping things together to make things simpler. Okay? So, here you go. So a farmer might group his animals in order to feed them. So he's got some cows that look rather like pigs on this side. Okay? They look a little like pigs with little faces. I know. I've never seen it.
They're not cows. They are bulls.
Oh, right. They're bulls. But they have udders and horns. So they're cows with horns. Okay.
Maybe they're pigs like pigs.
I don't think they're pigs. Pigs don't have horns. All right.
His face looks like a pig.
I know. See, that's what I was saying.
Maybe
I don't know. They're pig cows. All right.
Pig cows.
Moving over here, we have some what? Sheep. So, he's separating the two types of animals together. But on this side, he has how many cows?
3.
On this side, he has how many sheep?
3.
You wouldn't say he has 1 sheep, 1 sheep, 1 sheep. You'd say he has 3 sheep. Right? That's the crux of the lesson. If you can do that, then you can do what we're doing today. Okay? So keep it in mind. Algebra is not about some mystical, weird system. It's just a way of writing things mathematically that you do all the time anyway. Okay? Here we go. So we can do grouping to achieve a similar thing in math. So if you look here, the sloth has all the U's stacked together, the Z's stacked together, and the X's stacked together. Right? Yeah, so he's still working on it. Okay? All right. So look at these cards. Would it be easier just to say I have a jack, a queen, a jack, a king, or would it be easier to group the like objects together?
Three.
Exactly. So I have how many jacks? How many queens? One queen. How many kings? Two kings. That's much easier to group them together, is it not? Okay. All right. So here, that's all they've done is they've given you different colors so that they make it easier to find, easier to see them. But like terms or like items can be combined, okay, or collected. So here you go, nice and neat. It tells you how many cards you have. 2 kings, 1 queen, 3 jacks. Remember when you were looking at the algebraic conventions, get used to it. All right, so here we go. So remember, in our algebraic conventions, we learned that we can give initials to stand for different items, like you had the boat and the oars. So for kings, we use K. For queens, we use Q. For jacks, we use J. So 2 kings. How come there's no number in front of the queen?
Because you don't need to write it because there's only one.
Exactly. If there's only one item, then you just need the name of the item. You don't need a number in front of it. Could I put a 1 in front of it and still be correct? Absolutely. And if it makes your life easier, put the 1s in. Okay? Different people will do different things. All right? All right, so you get the idea that we can group things that are like. Well, in order to do that, we need to be able to tell that things are alike objects. Here, once you know that these are cows and these are sheep, it's easy to group them, right? So just keep that in mind as we go when we're working with algebraic terms. And what's the base of every term? It's the variable, right? Okay? And so if it's the base, that's the thing that tells you what it is. Okay? Good. All right. So here we go. In algebraic expressions, we call things that are the same like terms. So here we have 3 what? Cows plus 2 what? Plus 4 what? Yes.
Why don't they just put 6 sheep?
Well, hold on, because they're trying to show you something. So, now, these 2 items are the same kind of items, are they not?
Yes.
Therefore, do we need to say them separately? No. We can combine them. Right? And since they're like terms, we can combine them. So what would you say? 3 cows and what?
6 sheep.
6 sheep. Okay? So they're just trying to make a point. All right, here we go. We can do the same thing with terms, algebraic terms. Here in this expression, I have 2 p's. I have a number term. Remember, there are still number terms. So the number 1. And then this one has a what in it?
Y.
So even though it's a fraction, it's still a y term because it has a y in it. Yeah? So that's a p term, that's a p term, that's a number term, and that's a y term. Are any of them like terms? No. But this one has numbers in it. Doesn't that make it a number term?
No.
Nope, because it has a y in it. That makes it a y term. Okay? So keep that in mind. Variable terms can have numbers in them. Number terms are only number terms, or just numbers. Okay? All right, so here you go. We're back to those cows and sheep. The sheep are like terms, therefore we can combine them. Here we're doing the same thing. This is 4 what term kind of things? X's, and this is also another X. Therefore, they can be combined. What do you think 4 of them plus another one is? 5 X's. There you go. Okay? Now, when you have more than one letter, you can still have more than one letter and have it be a term if they're connected. So this is a ZW term. And this is also a ZW term. Or Z. Okay. All right. Now, because one of your algebraic conventions is that if you have more than one letter, you always write them in what kind of order? Alphabetical order. And so be careful. Yes, so be careful. Always make sure that you put them in alphabetical order. So which one comes first, Z or W? W? So we should really write this as WZ. Now that they're in the same order, it makes it much easier to see that they are indeed like terms. So how many of them do I have here first?
2.
Well, be careful. It's 2 letters, but how many terms? What number's in front of them? There you go. 1 of them. And how many do I have here? Another 1. So that makes how many? 2 WZ. Okay? So more than 1 letter, they can still be like terms. Okay? Just make sure to put the letters in alphabetical order so you can see that they're like terms. They'll do that to you quite a lot, right? So they may give you AB and BA. Are those like terms?
Yes.
Absolutely, because this one shouldn't be a BA, it should be a what?
AB.
AB. Okay? So get in the habit of cleaning them up if you see them, if they're not in alphabetical order. Okay? So here we go. Identify the like terms in the expression below. Go, and then I'm going to call on somebody to help me out. Okay, so we had AB terms, we combined. We had A terms, we combined. We had B terms, which we couldn't combine because there weren't any more B terms. Okay? Right. It's important that you always group like terms together, because if you don't, then it makes it more difficult to see. You don't want to have something that has 20 terms when you can combine all of the like terms and have something that has 2 terms, right? Make sense? So you clean it up. Just like you wouldn't come in here and say, there's 1 student, there's 1 student, there's 1 student, there's 1 student, there's 1 student. You would get really sick of that pretty quickly, wouldn't you? All right? Same idea. Okay? So here we go. So here I have 7 A's plus 2 A's plus 1 A plus 3 A's. Are they all like terms? Yes, they're all what kinds of terms? A terms. Therefore, they can all be combined. So 7 plus 2 makes 9, plus 1 more makes 10, plus 3 more makes 13 A's. So you're just adding up the numbers. Now, did they change? Are they now A something else? No, they're still A's, just like 2 students plus 3 students plus 4 more students. They stay students, right? Okay? All right. So you can have more than 1 letter, so be careful. Just make sure that you're careful about the letters. And first of all, the first thing you need to do is you should always go through and see if it does have more than 1 letter, they need to be in what?
The alphabetical order.
Alphabetical order. Okay? Yes. Okay, so CD and CD, those are like terms. Do you agree? So 4 CDs, but be careful, that's not plus 2, it's what? So what's 4 CDs minus 2 CDs going to give? 2 CDs, right? Now I'm done with the CDs. This is an FG, and that's a GF, so they're not like terms, are they?
Yes, they are.
Yes, they are. What's wrong with them? One of them is not in alphabetical order. So which comes first, G or F? S. So this one should actually be plus 3 FG. And once you see that, then you can easily see that they're like terms. How many of them do I have here if there's no number in front? 1. And positive 1 of them plus 3 of them makes
4.
how many? What kind of 4? Positive 4 FG. Remember, we said earlier when we introduced the idea of terms, there's no such thing as a 4. There's a positive 4 and a what? Negative 4. You must say the sign from this point forward. Okay? All right. And there we are. We've combined those like terms. So the next slide, all they're going to do is combine them. All right. Here goes a little chart. 2A and 2. Are they like terms? No, because one is an A term and the other, and the plain old 2, what do you call that? Is just a number term. Excellent. Good. 2A and 2B, like terms? No, because the variables are not the same. Good job. A and 5A, like terms? Yes, they're both A terms, right? How many A's in the first one?
1.
Yeah, positive 1 of them, plus 5 more of them would have made positive 6. Positive 6 of them. Okay. Excellent job, guys. All right. So, I know that you guys are way more sophisticated than sheep and cows, but it really drives home the point if you'll think about it like this in terms of these things. These are actual objects. We just don't know what objects they are, when they're x's and y's. But they stand for some number, so they stand for some objects. So, do I have any like objects here? Sure. The first object is a what?
Cow.
And how many cows do I have?
3 cows.
And then are there any more cows up there?
Yes, they are.
Yep, positive 5. So what's positive 3 plus 5 going to make?
8.
Positive 8 cows. Now I'm not going to draw a cow. Okay, just going to write C. Now, here we have positive 4 what? Sheep. Plus 2 more sheep makes what? Positive 6 sheep. Okay. How excited?
I'm so confused about the positive thing.
Okay. Well, we're both positive, so that means you're just going to get plus between them. Okay. So they're just going to stay positive. Yes, ma'am.
What is cow and then sheep and then sheep and cow? What do you know what one goes first?
Well, hold on.
Because
It doesn't matter.
So it doesn't matter.
Doesn't matter.
If they're like-
Okay. You can group them in any order. So if you like the sheep better, put the sheep first.
It would change the equation, so it doesn't matter.
Yeah. Or the expression. Yes.
Yeah.
Okay. 4 sheep plus 2 sheep, 6 sheep, right? And then cows. What's wrong with this?
Well, you can't add the X and the sheep together because they're not the same.
Well, the X is saying don't do that. What have they done? Look at the face.
They made a cow into a sheep.
Exactly. They put a cow and sheep together to make one object, and that's not allowed. And so make sure you remember that. Here we go. Collect the like terms. Are we ready?
No.
So watch those signs. Be very careful about whether it's you're adding them, combining them, adding them together, or subtracting them. So watch your signs. Okay. So what we're going to do is I'm going to give you an assignment here. You can work on some of it now, and then but the rest of it is homework. I expect it to be done before we meet again. Got it? So that does not mean